I'll leave that running as well. So thank you for joining. This is a very odd. I'm still trying to work out the problems with Catalina and streaming, but this may be a solution once I get used to it and remember to send to live stream. So yeah, here we go. I'm on my Chromebox, and Chris Whaley, good friend of mine. He posted a tweet yesterday. Was it yesterday? Anyway, JavaScript's array prototype lacks a partition with function, so I wrote one. Now, I've learned a lot from Chris in the past, so I was very eager to see what he was talking about. And I think you will be too. So we've had a bit of a fun time chatting about this. So I wanted to explore that and explore partitioning in general, and explore partitioning from how Chris and I would approach implementing a partition feature, and also have a look at how Ramda implements their partition feature. Anyway, I've got a beer. It's from Tanker, and they're from Estonia, aren't they? Tanker? I can't see. I've not got my glasses on. Tanker Reloaded. It's just an IPA. So, Max, if you're watching, this is an IPA, not an API. I'm going to have this IPA, and we'll open up here. I can go to the chat. There we go. Perfect. I can see the chat on my phone. Perfect. I'll open up the chat, and we can have a look together at Chris's code here. I'll pour the beer while we're having a look at this code. By the way, especially for the occasion, I've donned my new T-shirt from Spreadshirt. Not that does not work on Windows one, but a new T-shirt that says Functor, which for those functional programming wonks out there, I guess you'll know what that is and why I put that on there. I think I quite like the word functor. Maybe we'll talk about what functors are another time. Quite dry. So actually to think about what partitioning is, we can see here. So what Chris says is partition with takes a simple predicate function. A predicate function is a function that returns a Boolean value, true or false. And that's quite a common thing in functional programming. And also returns an array containing two other arrays. So of course, partition with takes a predicate function, but it also then operates on an array of things. And it returns an array containing two subarrays. Okay, the first array contains all the elements that don't match the predicate. And the second, all the elements that do match the predicate. And really nice example here. In fact, what I'd said to Chris was that I tried to implement a partition function in JavaScript on my own before looking at this code. Mine looked quite different actually. So we'll look at that as well. But I used also the classic sort of is even function or is odd function, right? So is even is a function. Chris, why have we used var, by the way, and not const? But anyway, maybe you can answer. In fact, I can't see. Oh, I can see the chat down there. Yeah, my wife is just leaving work, so that's good. We've got a bit of time. So the is even function is a function that takes an x and returns true if x mod 2 equals 0. So when you divide x by 2, if there's 0 remaining, then it's even, of course, okay? And that's quite a nice sort of explicit, the answer from this has to be 0, okay? And there's a strict equals there. So we've got a function, and what I think we'll do is we'll play around with some of this stuff. So I've got a little Ramda REPL. Ramda is a functional programming library for JavaScript, which I'm a big fan of. And it's also got a REPL, which is very, very useful too, just for doing some sort of live JavaScript. Sometimes I'll use the Chrome browser, but I also want to reuse some Ramda functions eventually. So yeah. So we've got here, I'll tell you what, I notice it's just you and me, Chris. What I'll do is I'll just live. live streaming now, and I will add here, hey folks, I'm live on streaming on Twitch, looking at some relaxing functional programming aspects with Chris. Ooh. Really? I always pronounce your name wrong. Oh, what we're talking about. Logarithm. Come and join us, grab a beer and pop into GPQ macro 99 right now. Functional programming. Yeah, okay, perfect. Let's do that. Right, so we've done that, so people may know. Okay, so in here, let's define this. Let's copy this function. Yeah, that's right. Yeah. Const is even is a function is something that takes an x, and if the x mod 2 equals 0, there we go. So if we can say, for example, is even 3 or 4, that's true. 3 is false. Hey, hola, Max. Good evening to you. Good evening. I hope you've got your IPA. I've got on my new T-shirt on, by the way, Functor. There we go. So we're just having a look at some functional programming. Hola. So yeah, let us know what beer you're drinking. So there's an is even function. That's really nice. So we can use that as the predicate function in Chris's example. And we've got some numbers. Let's define those as well. So const numbers. I'm going to say numbers equals, instead of saying what, yeah, let's have range. Let's use the Ramda range function. I've not really talked about Ramda yet, but let's use the Ramda range function, which is a bit like the Python range function. So we can see here numbers, they are 1 through 9. Okay, that's for the range 10. If you're interested in Ramda and these functions here, let me move that back here. Ramda docs, we can see the range function. Range, oh, hold on, the range. There's range there. Okay, so the range takes a number and another number and produces an array of numbers. Okay, returns a list of numbers from inclusive to exclusive. Okay, so that's a nice function. Normally, when you import Ramda, you have to import it and assign it to the a global constant r, then r.range. But in the Ramda REPL, you don't have to have the r. prefix. Hey, Robertino, howdy, and Codebase, hi, welcome, Codebase Alpha. So anybody who doesn't know, Codebase Alpha does some awesome live streams, also here on Twitch. So you should follow Codebase Alpha. Codebase, put your Twitch ID in the chat here so people can follow you, and then I'll also tweet it. So anyway, this is a nice little range function. So let's go back to Chris's example, and the idea is that we want to split out these numbers in this example into all the odd numbers and all the even numbers. So Chris's premise is he wants to be able to call a partition with function on the numbers array, give it a predicate is even, and then that should produce 2 arrays. Okay, so well, in fact, that should produce an array of 2 subarrays. Yeah, so yeah, definitely follow Codebase Alpha. Let's get his follower count up. Oh no, Robert, you didn't miss me this morning because I'm not streaming yet fully because I'm still struggling with Catalina. But I'm hoping that this approach using Chrome OS is going to be much better. I'm using Lightstream, which I'm struggling with because it's probably my brain and it's Friday evening and I'm tired. But anyway, so you didn't miss anything. So yeah, partition with is even, pass it that predicate function, and what we should end up with is an array of 2 arrays, which in Chris's beautiful example here, he's using destructuring to pull out those subarrays into two variables, odd and even. And odd will be 1, 3, 5, 7, 9, and even will be 2, 4, 6, 8, 10. So we'll come back to, well, in fact, yeah, we'll come back to that in a second. Let's have a look at what, yeah, maybe let's have a look at what I was implementing first, and then we'll look at Chris's, because Chris's is slightly more involved, also slightly more beautiful, and he was adhering to a number of, or conforming, let me say, conforming to a number of academic principles. Let me go back here. By the way, I'm using this really nice tiling window manager on Chrome OS that I found. So yeah, all sorts of different layouts. Anyway, so Chris's original requirement upon himself was to extend the array prototype. Okay, so one of the beautiful things about JavaScript is that it's very flexible, and you can extend sort of core object types with extra functions. So let's do that here. So why don't we say array dot, oh, in fact, well, yeah, what we want to do is effectively, let's explore applying the is even predicate to the numbers range. So we could say, for example, numbers in plain JavaScript, numbers dot filter. So this is a higher order function that takes another function, is even. And that should give us 2, 4, 6, 8. Okay, so we want to be able to sort of do that sort of thing, but we want to be able to say numbers dot partition, and then, oh, let's call it partition with. I mean, well, let's call mine partition, and let's call Chris's partition with, so we're not confusing ourselves. Numbers dot partition, and we want to be able to pass it this is even. Okay, and we want then as output an array of 2 subarrays. So that's what we need to implement. By the way I'm talking about this sort of thing, and also Ramda, is an absolutely awesome chap on YouTube. I've been watching some of his videos recently. Oh, there's one there, for example. Christopher Okravi, watch history. There we go. I went down here to watch it. Christopher, there we go. So Christopher Okravi, if you search for Christopher Okravi, he's doing a number of videos, or he has done a number of videos in a playlist all about the Ramda functions. Okay, so have a look at those, all playlists. I'm sure it's somewhere. I can't see exactly. Oh, there's more. Ramda JS tutorial is 41, and he goes through each of the Ramda functions. Definitely recommended. Okay, so yeah, what we want to do is implement something. Now, this is what I've implemented. I'm going to bring it up here, but I'm going to actually type it out myself as we go. So let me make this a little bit bigger that way. So we want to be able to do that, but we can't right now. So we'll add a function on the array prototype, and we'll call it partition. And we can pass it something. And if we say console.log hello world, for example, this is how you can define something. And then we can say here, let's bring that down there, numbers.partition is even hello world. And that doesn't give us anything. That doesn't return anything. Okay. If we say a return 42, there we go. So hello world 42. So that's how you add a new function to the array object, for example. And this will then be, the partition function will be available on all arrays. And that's what Chris is trying to do, right, Chris? So what we want to do here is say, we'll accept a function, accept this predicate function, okay? And what we want to do is apply that predicate function to the array, to the contents of the array, which is available to us in the prototype context via the this keyword. So if we say here, and what I'm doing, as you can see, what I'm doing here is I'm using a this.reduce. why don't we say here, first of all, console.log this. Let's see what happens. There we go. So this, we can see this is the actual array. So this is the numbers array in this case, 1, 2, 3, 4, 5, 6, 7, 8. Notice, by the way, that in the Ramda REPL, which is wonderful, the console logged output doesn't clear. If I can actually refresh this page, hopefully, I just press refresh, so it's too late now anyway. But yeah, so the wonderful way that this works is that the actual code is encoded in the URL hash path of the URL where we are. So every time we edit this, the hash path changes. So it's beautiful. So there we go. There's the actual answer right now from what we've got in this partition function. So we need to export. We need to change this so that it will do what we want. So let's get rid of this console.log. Well, let's keep that for now. What we really want to do is transform that 1, 2, 3, 4, 5, 6, 7, 8, 9 in this case to a subarray, which is, so we want to transform it into something like this, right? Let me just put comments in there. We want to transform it into something that goes is even, so it's going to be 2, 4, 6, 8, 1, 3, 5, 7, 9. So that's what we want to output. You know, this is sort of reminds me of sort of a, test-driven development. Just do that and you've passed your test, right? But that's what we want to output. And we can use, and Chris uses this as well, because reduce is, I think it's fair to say, well, actually, drinking beer on a live stream is great, but it makes you burp a little bit. Have you got a beer yet, Max? This is quite dry, actually. It's okay. Tanker reloaded. Anyway, the reduce is like the mother of all functions. It's actually an amazing mechanism. So we'll say this dot reduce. We know this is the actual 1, 2, 3, 4, 5, 6, 7, 8, 9. And reduce takes a function that is passed the accumulator and each one of the elements one by one. But it also takes, let's just put that second, it also takes an initial value. And that initial value, a lot of times people think reduce will reduce an array, for example, well, reduce an array in this case, always, to a scalar, to, some total. But reduce can change an array into any shape of object. And we're going to reduce it into something that has a starting value of basically what we want to get to. Okay. Now, that function, the reduce function, is given an accumulator, which initially, for the first call, is always the starting value. And then it's passed, for the first time it's passed the first item of this, which is 1, and A is that. And the second time it's passed 2 with the accumulator, whatever we return, and the third time, and so on. So if we do something, if we write something like this, let's do it in a really sort of long-winded way first. So if we say, for example, here, if f of a, so this is basically our f is our predicate. F is our predicate function. Sorry, not of a, of x. Let's apply f to x, and if it's true, then we want to push onto the first subarray x. Okay, so if x is true as far as applying f to it, then we want to push it onto the first array. Otherwise, I'm just sort of making this up, but otherwise, we want to push it onto the second array where it's not true, where the application of the predicate function f is not true on that particular value. It gets put in the second, as in a brackets 1 subarray. And then, of course, we've got to return the array, which is a. So let's see what that gives us. Now, let me just move that over here a little bit. There we go. Is that still let's make it, yeah, okay, that'll do. Yes, exactly. So Chris says the map function is simply a special case of the reduce function, as is the filter function, as is the find function. Special case, yes. I think you could also say that filter is implemented using reduce. Map is implemented using reduce. So Chris says, my implementation pushes the false elements into the first array, but whatever. Okay, wrong way around, but it doesn't really matter. Or different way around. Let's say different way around. So let's just refresh that to get rid of that output, that console log output. In fact, let me just get rid of the console log output entirely. Ooh, some fireworks going on there. What's going on outside? So we're not returning anything right now. So there we go. So if we now say return, there we go. We got it. Okay. So let's just make sure we understand this. We're passing a predicate function f. In this case, it's is even. That predicate function is used to work out whether x fulfills what f represents, that predicate function. And if it does, it puts x, it pushes it onto the first subarray. Otherwise, it pushes it onto the second subarray. Now, all I did here was reduce that down to a, now reduce, see what I did there? Reduce, cut that down to a single line, because really, why not? So what we can say here is, let's just return, let's not get rid of that as well. We could say A, and then we need to work out whether it's the first subarray or the second subarray. So why don't we use the ternary operator? So we'll do the test with the predicate function. And if that is true, we want to output, or not output, we want to have that evaluate to 0. So it'll be the 0th, as in the first subarray. Otherwise, the 1th, as in the second subarray, dot push of x. And then, of course, we've also got to return A as well. What's going on here? A of x, push x out, push x and A. Oh, yeah, of course. Now, the reason that's not working, that's exactly the same code here. However, the reason that is not working is because I put, for the previous reasons, I put curly braces round the function definition, which means that I do have to explicitly say return. So if I say return A here, that should work, right? But what we want to avoid is that. So we can now say, there we go. So that's what I came up with. And again, for those not versed in reading code as terse as this, then it looks a little bit weird. But once you stare at it for long enough, I think it becomes something that is a lot easier to comprehend. Now, Tom online on Twitter before was complaining about fat arrows, but Tom, you're not here, so come on and challenge this. Yes, remove the curly brackets. Thank you. Yeah, I do like the syntax here as well. I like the style. So we've got that. So that is adding a partition function to the array object. So why don't we now turn to Chris's? Let's just make that a little bit smaller again. Let's bring that over there. Let's go back to Chris's. Is that too big? I'll see that. I want to reduce this. One of the things there we go. That's why. Yeah. One of the things I'm doing is having to use 720p. I'm doing 60 frames per second, but Lightstream only supports 720p resolution at the moment. They say they're working on 1080, which would be awesome. So what I've done to avoid any sort of encoding extra work, I've switched my 4K monitor from 3000 whatever it is down to 1280 by 720, which is 720p. so that there's no sort of downscaling required. Oh, 1 second. That was my darling wife calling. I just cut her off. I hope that's okay. From Vodafone, you missed a call. Yes, I know I missed a call. Thank you. So let's have a look now at Chris's. Now, Chris, I'm sure you will add to the chat if you want to add any explanation. I can't see it, but I think, can you tell me in the chat, you should be able to see the chat overlaid over my actual display. Can you tell me whether you can or cannot see that? Anyway, let's just refresh that, get rid of that sort of console.log there. There we go, numbers partition, wonderful. So what Chris's does is, well, why don't we do, well, let me add that and explore it like that, okay? So const partition with is a function, and of course what Chris is going to do there, I guess, is then, there we go, yeah, add that to the array product. So let's do that as well, okay? Oops, let's copy that. So we've got now also, oh, not utils, dot partition with, I guess, there, right. So we've now also, not only have we got a partition function on the array, but we've also got a partition with, which is Chris's, right? Thank you, thanks, Robertino. So let's have a go through this. It is slightly more involved, slightly more academic. However, it's doing more or less the same thing. So we're defining this function, which is here. And this function itself is the one that takes the predicate function. So this pred fn is the equivalent of the f here. But then what Chris does is define a reducer function as a constant here within this block scope. This reducer function is doing exactly the same thing. First of all, it's taking the accumulator and the individual element, okay, L or X. And what it does is something really actually quite beautiful, I think, which is this thing here. If you look at the brackets here and here, now if I'm not mistaken, that is called an IIFE, an immediately invoked, no, an immediately inline function execution, or some immediately invoked function expression. Yes, IIFE, immediately invoked function expression. So it's a single expression, first of all, and that expression consists of a function definition there, and then that function definition, wrapped in brackets, called, executed, invoked with a single argument, which is this, the result of the predicate function on that given element. So it's quite, yeah, I think it's, so Robert, you like the readability of which solution, Chris's or mine, or both, or both. Chris's solution is more academic, and I think more beautiful as well. So what this is doing is like basically, if the result of calling the predicate function on this given element, of course, don't forget this is still within the partition reducer context. You know, the result of that we're gonna capture in the success argument, and if it is successful, Boolean wise, this is the ternary operator again, interestingly enough, then what we return is the accumulator's first sub array and the accumulator's second subarray with that extra element concatenated into it, pushed into it. Now, this is what Chris was saying before. He got the elements pushed into the wrong way around. So really what we're looking for here is, if I put that there, where's it gone? And that there, that's what we really should be looking for, right? I'm guessing. Let's make that a little bit smaller or bigger, rather. So if we say now numbers partition with is even, there we go. It works as well. So that's partition. Now, do we want to, Chris's, of course. Yes, exactly. Chris's is a lot nicer, a lot more beautiful. I mean, I was deliberately trying to do a bit of, functional programming golf and do it all in one line. But yeah, this is really nice. And also, this structure here really shows you, literally, not physically, but visually, what's being returned. What's being returned is an array of 2 arrays where the first array is having an extra element added onto it, right? And this is returning 2 arrays where the second subarray is having something added onto it. And I like also the way that this is this immediately invoked function expression. But of course, also don't forget that once we've defined this, once Chris has defined this partition reducer, he's using that in the context of a reduction on the this, which is the 1, 2, 3, 4, 5, 6, 7, 8, 9, starting with the same starting value that I had, of course, which is this thing over here. Now, one thing that yes, the use of concat allows the element to be an entire array, which of course in our case is not the case, but it could be, yeah. Now, what I did was, having enjoyed Chris's implementation of partition or partition with, I thought, well, Ramda is a functional programming library and has all these beautiful functions. And Ramda has a partition with as well. So if I get rid of all of this, apart from those 2 constants there, there's a partition function that's defined in Ramda. Outside of this particular REPL, you'd have to say r.partition, for example. So we can say our partition is even, and we get the same thing. Now, one of the interesting things to note there is that, of course, this partition function is independent of, not attached to, any instance of any array. In JavaScript, the higher order functions, I suppose, belong to, are attached almost like as methods on instances of these different objects, like an array object. Okay, so array dot, some array dot map, some array dot filter, some array dot partition in this case. However, the way that Ramda implements these functional programming functions is as standalone functions, and it implements them the right way around. So there's a brilliant talk by, his name completely escapes, Dr. Boolean on Twitter. What's his real name? Is it Jeff? No. I'm so embarrassed I can't remember his name. Dr. Boolean on Twitter. I've learned so much from him. And he did a talk called Underscore You're Doing It Wrong. And it was all about the way that Underscore provided functional programming functions, but the way you had to use them was counterproductive to the way that your mind works when you're programming in a functional way. Because what you want to do is you want to say, for example, const split even equals partition is even. So what we're doing there is we're partially applying the partition function by supplying it only with one argument. The partition function, if we go to the documentation, in fact, partition basically takes a function, a predicate function, as the first argument, and as the second argument takes an array, right? However, because every single function in Ramda is curried, and a curried function is a function that, let's say, it has, it's waiting for 3 arguments. If you pass it one argument, it will produce a function that's waiting for the remaining two. And then you pass that one another argument, and it produces a function that's waiting for the remaining argument, and so on. Anyway, I think you all know about Kareem. So I've partially applied partition here to create a new function called split even. And I can say split even on those numbers, and it produces the same thing. Let's just do it so we can see that it's changed. Yeah, there we go. So we can now create functions from other functions. And this leads me on very nicely to the way that Ramda actually implements their partition function. So Ramda is, like I say, a JavaScript library written in JavaScript. If we go to, did I have it up here? No. Ramda GitHub. Oh, yeah, I had a look at it, so it's in my history here. And there's all sorts of documentation here, just like Chris's gist. But basically at the bottom, this is the implementation of partition. And the thing is, yes, exactly. The Ramda solution is so much better than both of our solutions. The beautiful thing is that, of course, one of the tenets of functional programming is small pieces loosely joined, and you build up functions by composing other functions and using functions together. So let's just have a look at this for a second. Let's just put that there. We've already got partition. We've already got partition declared. So let's say, let's call it partition Z. Okay, why not? So let's just get rid of all that as well. So the way that partition is defined in Ramda is by using three functions. It's using the juxt function, and it's using the filter function and the reject function. So if we explore what the filter function is first, filter, well, in fact, documentation, filter, it might be, we can actually look here, I suppose, can't we? Yes, range, filter. The filter function takes a predicate and a filterable, in this case an array, and returns a new filterable of the same type containing the members of the given filterable which satisfy that given predicate. So basically it's like array.filter in sort of standard JavaScript. So if we say filter is even, comma, numbers, we're going to get the even numbers from that range, right? We could even say evens only equals filter is even, again, using this partial application, const, and then we can say evens only of numbers, get rid of that one, there we go. So again, this is just sort of a beautiful way of thinking about building up your code from, small pieces. So, so that's filter, okay. Reject is the opposite of filter. The reject is the complement to filter, as in, yeah, the opposite. So if we say reject, in fact, let's call this not the evens, of the numbers. There we go. There's not the evens, as in the odds, as this is all of the entries in this numbers array where applying the predicate to each one results in a false, not a true. Now, given that we know then what that means, let's actually put that there. So we can say, if we say filter is even numbers, that gives us, let's get rid of those things there. That gives us that. Let's go back to 10 because it's just easier to see. That will give us that. Okay, so we understand what's going on. And we know that also reject is even numbers, event is even numbers, that will give us those, right? So let's just bear that in mind. Okay. So now what does this juxt do? Let's go to juxt. Juxt applies a list of functions to a list of values. I found when I was looking at this, I found that is not a great explanation, but when you expand the parameters, it does make more sense. I have a bit more beer. We can see that it takes an array of functions. So that's why we've got that there. So in this particular implementation, in the Ramda implementation of partition, we're getting juxt called with the first argument only, a list of functions, an array of functions. Where's the second argument? There isn't one, as in it's been partially applied. So partition is yet another example of something that's been partially applied. We're partially applying the function juxt, because what juxt also takes is a list of well, actually no, it doesn't take that, does it? No, actually that's nonsense. It returns a function which we can then use. Yeah, okay, so we're not partially applying it. It returns a function. It's effectively the same as partially applying in this particular case, but it returns a function that returns a list of values after applying each of the original functions to its parameters. That sounds a bit weird, so let me try this example here. If we say get range is math.min and math.max. So if we now say get range of, as it says here, 3, 4, 9, minus 3, and then get what? Why is that not get range juxt? Get range. Why is that telling me? Juxt of that. That's okay. Ah, wait. That's not a list. That's an array. There we go. Okay, so we get minus 3 and 9. Why do we get minus 3 and 9? Because first of all, we apply math.min to these numbers. Math.min to 3, 4, what is it? 9 and minus 3 is minus 3, right? And math.max is 9. Okay, so it's exactly the same as saying, well, let's take the first function in this list, math.min, apply it to the list of values here, put that answer in there, and then take the second function and take the third if there is any, and so on, and apply it to the same list of values. So let's go back there, get range, let's get rid of that. So Michelle coming home. Yes. So that's that. So that's get range. So what is this doing here? What we're doing here is we are saying apply filter and apply reject. Notice that the result of the first function application is put as the first value in this output array. And the result of applying the second one is the second value. Now, if we go down here and say, let's add this here. Let's bring this down here now. Hi, hon, I'm just doing a quick live stream. I'm almost finished, actually. That's why I had to reject you on the phone. So if we now, let's leave those there. Let's get rid of that get range. Hello. Partition, let's call it partition Z because we've already got a partition. That's not really going to tell us much, is it? No. Okay, so if we now say partition Z on what numbers? Yeah, okay. We'll put them in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's going on? Partition Z. Juxt filter partition. Wait a minute. What's going on? Ah, yeah, of course. We need to specify first of all going on here now? What's going on? Partition Z. Partition. Hold on. Partition. How do we do the partition? My brain is suddenly frozen. Partition. Oh yeah, here we go. Partition, and then we provide the is even in the numbers. We get that. Now, how does that work? That's effectively saying juxtapose the filter with is even and the reject with is even on the numbers. So now let's do that. So that should produce us. Yeah. Okay. Let's just do this one by one. We can say now var split on even. Naming things is hard. Partition Z is even, right? Split on even. Split on even on a list of numbers now. Oop. What's going on? There we go. Numbers there. Okay, that works. Okay, Chris, thanks for joining. I think we're almost done anyway, right? What time is it now? Oh, it's 7 o'clock already. So let's just make sure we understand this. This juxt providing filter and reject. In fact, why don't we change these around? Reject and then filter to do a a Chris Wheely version. Filter. We can now see that is 13579, as in where the is even has been rejected, as in where the predicate returns false for those values, and the filter is where they return true. Now, was that did I do that right? Yeah, there we go. It's changed around. Yeah, perfect. So yeah, I guess that was it. But when I looked at the implementation of partition in Ramda. Ramda is just bootstrapping itself, using the filter function of Ramda, using the reject function of Ramda, and then combining those two functions using the juxt function of Ramda. And that's it. That's the definition of partition. So it's, turtles all the way up. Yeah, I guess that's it. Thanks so much for joining. This was not something I would normally do on a Friday evening or in an afternoon anyway. I'm really tired in the afternoons, especially with the beer as well, which is very dry. But yeah, thank you very much. Hey, Killu. Sorry, I didn't notice that. Killu, thank you for joining. Hey, and thanks everyone. I hope you have a wonderful weekend. If this is interesting, maybe we can explore some more Ramda. I'm hoping to do the advent of code and use Ramda for it to learn a little bit more about Ramda. But if there's one thing you should do this weekend is start watching that that playlist from Chris O'Cravy on YouTube. It's absolutely awesome. Right, I'm going to switch back to my light stream and get rid of that and end the stream. Thanks very much.